Hello everyone. In today's lesson, we're going to talk about solving logarithmic equations. So let's get started. All right, in example 1, it says, can you solve a logarithmic equation? And they're giving us an equation that has logs on both sides. And right away, I'm thinking, okay, I want to get rid of the log base 3 because then I can work with what's inside. So in order to get rid of a log base 3, what I do is a big base 3, and whatever you do on one side, you do to the other side. But what's really nice is log base 3 and base 3 cancel on the left as well as the right side, leaving you with x plus 3 equals 8x plus 17. And then this becomes a problem from Algebra 1 where you would go ahead and move the x's on one side and the numbers on the other side. So I'm going to go ahead and subtract x to the right side, and I'm left with 3 equals 7x plus 17. And then I'm going to go ahead and subtract 17 to the left side. And I'm going to just show the answer here. We get negative 14 because 3 minus 17 equals negative 14, and then the 7x drops. Last step is to get rid of that 7 by dividing 7 on both sides, and x equals negative 2. Okay, so that's our x value. Now, with the logs, you do have to be extra careful to see if these actually work. So I am going to go ahead and check our work, and I'm going to show you how to do this on the calculator. Okay, so on the calculator, I'm going to just go ahead and take this out, and I'm going to type in what I see, which is, oh, sorry. Actually, let me write it out first. So I have, log base 3, and then we have negative 2 plus 3 equals log base 3 of 8 times negative 2 plus 17. And I'm just going to simplify those to see if they are equal. So log base 3, negative 2 plus 3 is 1. And log base 3 of negative 16 plus 17 is also 1. And I can physically see that they are equal. Therefore, x equals negative 2 is a solution. So actually, I didn't even need the calculator on that one, but I will show you ones where you might need to check it out on the calculator. All right, let's go ahead and look at the next example. It says exponentiation of each side. So what this means is, and that's actually what I did on the example 1, it's just that both of the logs ended up canceling. Here, there's only one log on the left side. And so my initial response is get the log alone, which this log is alone. And then my other response is get rid of the log. So I see a log base 5, and right away I do base 5 on both sides. And log base 5 and base 5 cancel on the left side. And negative 3x plus 1 drops down. And this becomes 5 squared. And that's negative 3x plus 1, and 5 squared is 25. So now we're back to Algebra 1 again. So subtract 1 on both sides. Negative 3x equals 24. Divide by negative 3, and x equals negative 8. So that's our answer. I'm just boxing it for right now, but I do want to check my work to make sure if this works. So I have log base 5 of negative 3, and I'm going to substitute in the negative 8 plus 1 equals 2. So I want to know log base 5. All right, let's see what this number is. So I'm going to, negative 3 times negative 8 is 24, plus 1 is 25. And I'm going to type this into the calculator as a change of base. So I'm going to type log 25 divided by log 5 to see if that equals 2. If it does, then I know we are good to go. All right, let's check it out. So log 25, close it up, divided by log 5, and enter 2, which is what we wanted. So 2 equals 2, and that is perfect, so that works. All right, let's go on to the next one. All right, let's look at B. We have solve log base 8 of x minus 4 equals 2. So first thing is log is alone, which is great. Now we just have to get rid of the log base 8 by doing base 8 on both sides of the equation. Log base 8 and 8 cancel out. We are left with x minus 4 equals 8 squared, which is technically 64. And then from there we can go ahead and add the 4 to both sides. and x equals 68. So I'm going to box that out, but I do have to check the work. So let's go ahead and substitute it into the log to see what we get. So we have log base 8 of 68 minus 4 equals 2. And log base 8 of 68 minus 4 is 64. And what we want to know is log base 8 of 64 2. So on the calculator, I'm going to type log of 64 divided by log of 8. And I'm hoping that's going to be 2, but we will see in just a second. So let's clear this out. Log of 64, close the parentheses, divided by log of 8. And there's our 2. Perfect. So that again works. Done. Awesome job. All right, let's look at our next examples. So our next examples are a little different. It says, it's giving us a warning. These are the ones that could possibly have extraneous solutions, which really means false answers. And if they're false, then they're really not answers. Okay, so we would have to throw them out. So we have one more example we have to try. Now what's difficult about this problem is that there are 2 logs on the left side together. However, we know how to condense 2 logs into 1 log, especially if there's a plus sign between them. What we do is we take their components and we multiply them. So we're going to write log once, and we know that 5x is on top because it's positive, and x minus 1 is going to multiply to that because there's a positive sign between them, and that's going to equal 2. Okay, now there is no base number here, but really we know that it's a 10 because whenever they don't write it, we assume that it's a base 10. So we have log base 10, and I'm going to go ahead and distribute that 5x to the x and the 1. So I get 5x squared minus 5x equals 2. And then my job is to get rid of the log, base 10, by exponentiating on both sides but with a base 10. So I do base 10. And the left side cancels out, and we are left with 5x squared minus 5x equals 10 squared, which is 100. Now, I noticed the quadratic, so right away, my initial response is to get one side equal to 0. So I'm going to go ahead and move the 100 to the other side by subtracting it. And now we have everything on one side. And then I'm going to start the factoring process. What's nice about this problem is there is a GCF of a 5. So I'm going to pull that out first to make my life easier. So I have x squared minus x, and 100 divided by 5 is the 20, equals 0. And I'm going to move this over a little bit. Now I'm going to go ahead and factor out my trinomial. So x squared breaks down to x and x, and what I need is 2 numbers that multiply to negative 20 and add to negative 1. And the only one I can really think of is 5 and 4, because those multiply to 20, and there's a difference of 1. So I have to just figure out which one is the negative, and the 5 has to be the negative, and the 4 has to be the positive, so I can get that negative 1 that I want. And then I can solve each one separately. X minus 5 equals 0, and x equals 5. That could be an answer. I'll just box it out. And x equals negative 4 is the other answer. Actually, let me show you that work. It would just be x plus 4 equals 0, and then subtract the 4 to the other side. X equals negative 4 on the other side. Now, we do have to check both of them, because here what could happen is both could work or both could not work. So I'm going to check it. Now, what's nice is this is a log base 10, and I have a log base 10 button on my calculator. So I'm going to put it right into the calculator to see if it works. So here we go. Clear this out. So we have a log, and then I'm going to do 5 first. Check 5 first. So 5 times 5, close it up, plus log, again, and then it's x minus 1, but x is 5, so 5 minus 1. And I'm hoping this is equal to 2. And as you saw, it is equal to 2, so that means that x equals 5 actually works. Now I'm going to do the same thing with x equals negative 4 and to see if it's a solution or not. So let's check it out. So we have, let's clear this out, log of 5 times negative 4, close that parentheses, plus log of negative 4 minus 1, close that parentheses, and we ended up getting a non-real answer, which means it's not 2. So therefore, we can say that x equals negative 4 is not an answer. So the only solution is 5. All right. Well, that is all I have for today. I hope that was helpful. We are looking forward to seeing you in class and for all your questions. Have a great day. Bye.